everybody. Very good evening. Hi guys, very good evening and a warm welcome to Vedantu Enlite. What's up? How are you all? Am I audible and visible? Can you all see me and hear me? Or no? I still don't see myself. You will have to tell me. I guess now I'm live. Yeah, now I'm live. Hello guys. What's up? How are you? Okay, so quickly go and share this with your friends. Yes, I hope that you all know today we are doing 50 questions. Yes, 50 questions possibly in 1 hour. Let's see, okay? And of course, after that, whatever was left from the previous session, remember that P block, the noble gases we had to study. So we are going to study about that also. Hi, Anger Queen. Good evening. Good evening. Why is it Anger Queen? Are you always angry? It's quite an interesting name. But just curious, why is it Anger Queen? Are you always angry? Anyway, hi Aditya, hi Sherlock Holmes, audible, great, amazing, alright. So how are you all doing? How was your weekend? Yes, did you all study? Did you all do the assignment that I asked you all to do? Yes? Nobody has sent me any pictures. Yes, I asked you all that please do send me pictures of, of the notes that you have made. Please tell me that you have. Please tell me that you have because it's very important, yeah. And you all know that your JEE exams are almost knocking on the door. So do not take it very lightly, yeah. Yes. Do not take it very lightly. It's important that you do this. Alright, so let's begin. There are 50 questions in this session today, and all the 50 questions, there are some of them which are previous year questions, yes, some of them which are your practice questions, some of them are your basically mock questions, yes, so all of them we are going to take a look at, yes. Hi Santosh, hello Sanidhya, hi Tanushri, hi, Acha, you are angry girl in your house, okay, alright. Alright, so let's begin. Let's take a look at it. And all of these questions are from P block B. Is this Menti? No. Balaji, no Menti right here. But I'll tell you what, in the description box, you might find this thing. You might find a link of V quiz. You can do that. However, we are just going to, take a quiz right here like this. Like I'm going to ask you the question and you're going to answer me in the chat box. So, let us begin everybody, okay? Let us begin. Now that you are here, please do like, share it with your friends, call up more people so that, more the merrier. More people will be graduating from Vedantu and more people will be getting the selection from Vedantu, isn't it? So please go ahead and share it, okay? Maybe go somewhere else. Where do you want to go? I don't know. Where do you want to go? Bacha, where do you want to go? I don't know. Anyway, alright. Yeah, so do like, share and subscribe. Yes, also I have to tell you that Vedantu is the only platform, the only edtech company which believes and takes care of child safety. There is nowhere else where you will find it. We always believe that child safety, especially on online cyber bully, harassment, mental harassment, all of these happen so much, and that is why special care has been taken here so that no child faces it. And this time from the 7th of November to 14th of November, we are actually celebrating Online Child Safety Week, okay? So, we believe that child safety is first and then everything else, right? Chalo. So let's begin. Let's not waste any more time. And you all know my introduction, right? My name is Nabamita Ma'am and I'm your chemistry master teacher and I am taking care of inorganic chemistry on this channel. And with this note, the first question is on your screen. Everybody tell me, which of the following is the most abundant in the earth crust? Now this is typically from your NCERT. If you have just even gone through like just a glance of NCERT, you would know this. Chalo. You would know this. Tell me. Come on guys, everybody need your answers. Balaji, you are saying B. Okay, Kanan B. Kanan is also saying very good. Kids Universe, you are also saying the correct answer. Well done everybody. Well done. Yes, the correct answer is aluminium. Yes, the correct answer is aluminium. Well done. Kya baat hai? The very first question and you are giving it absolutely correct. Well done, well done. Good night already. No. Right now it's not good night. Hey, I did not even have my dinner. I'm gonna finish my class, then go home, then dinner, then sleep. So it's a little more time is left, yeah? A little more time is left, yes. Anyway, so here is the explanation also, as you can read it, everybody. The aluminium does not occur in free state. It's not like very free, but yes, you can find aluminium in, it is the most abundant metal in the earth's crust, and you will find that it is definitely like mixed up with something. It's definitely mixed up with something, and then you can find it, okay? Alright, everybody? Great. Moving on. Next question. This also you know, everybody, this also. I don't know anything about P block elements. Koti, Ravi, why? I actually took 2 sessions already. P block, one shot part 1 and one shot part 2. I have taken it. My dear student, please go watch it if you haven't. That is going to clear all your doubts. Okay? Please teach NCERT. Yes, my aim is All India Rank 1 in NEET UG. That's the name of a student here. That's very good. I love your ambition. I will. But what I plan to do is, like I have always told you, my strategy is to complete everything first at one shot. And then elaborately, we will come back to it, okay? We will do everything in detail. You don't have to worry about it. Promise. I will, okay? Yes. Okay. So what are you telling me? Ionization enthalpy for elements of group 13 follows the order. Please take a look at it carefully. Thank you, Varsha. Thank you so much. Tattva is a very good thing. Tattva, if you do Tattva properly and PYQs properly, then I think that's enough for you. But also do understand the concepts. Don't forget about the concepts. Don't think that only solving problems is going to get you somewhere, okay? Yes. Tell me, do you all see it? I can see mixed responses. Someone is telling D, someone is telling A. You forgot. Group 13, class 11. I have taught you this. Alright, let's check it out. The correct answer is option D. Very good. No. Suresh. How are you saying B, bro? Huh? It's D, no? It is D. See? You had to check out this part. Look at this. It is boron, aluminium, boron, gallium, aluminium, isn't it? There was an exception. Do you remember? There was an exception between aluminium, gallium, and indium and thallium. Do you remember this? I told you, because of the D and F electrons suddenly getting introduced. Do you remember this, everybody? We have done this, everybody. How can I purchase Tattva? Tattva, actually you get it on Vedantu, but let me ask that. I'm not very sure about how can you purchase it. Let me just ask. Give me one session, okay, Varsha? By the next session, I'll come up with this answer and I'll tell you. But I would require you to be there in the next session so that I can take care of that, okay? Yeah? Will you do that for me? Please do come for the next session. I'll tell you the answer. Yes. Everybody, are we all clear with this? Do we all remember this? If not, go back to P block. Watch it, but on a high speed. Okay. Watch it on a 1.5x or 1.25x. I think that way you can do the session also in less than 1 hour. You will not be wasting too much time as well. Yeah. Is this clear or not? Come on, everybody. Go ahead. Let me know. Thumbs up or a fire or something. Yo, yes, something. Be interactive, yeah. Otherwise, how will ma'am understand, huh? Am I God or what? I'm not God. You have to tell me. What is the fee for JEE aspirant? I'll tell you, okay? I'll tell you how to get into this. Okay, next question. This is also very easy. The relationship between the first, second and the third ionization enthalpies of each group, not just group 13, of each group or of each element is, what is it? Tell me. Anybody? Come on. What is the answer? You know this. Very easy. This is very easy. Very easy. I can see that R. Shanjay. Very good. I think you are the first one who gave me the correct answer. Very good. Can we all have a clap for Shanjay? Very good. Very good. Yes, it is option B. Why is it option B? Because we always know that to take out the first electron, it would be easier. But once, remember that example I gave you. See, for me to get angry once would be easier for you, right? It will be easier for you to make me angry once, but the moment I got angry once, after that I'll be very careful that no. With students I cannot be angry, because students are the ones, I mean, this is my job. My job is to teach you, right? So if I get angry with my students, then what's the point of me being a teacher? I think I should change my profession and go somewhere else, right? So I'll be careful. The same way here as well, the atoms are very careful, right? Once they have lost an electron, they're like, next time you come, I'll remember you. I'm not going to give you another electron, right? So they're going to be a little more careful. Now for the third one, they will be even more careful, and they will keep it closer, right? Obviously, because the protons are going to pull it close, isn't it? Yes? So we know this, right? Very good, everybody. Moving on. Now, the element which shows least metallic character is indium, boron, aluminium, gallium. What happens to the metallic character? What happens to the metallic character when you are going down in the group? Come on. Answer. I'm going to ask you the question, you are going to ask me. Why isn't Wasim sir taking classes? Bacha, Wasim sir is taking classes, however a little less in this channel, because he does have a lot of his bandwidth is stretched in a lot of other channels and a lot of other Vedantu work as well, and that's why I stepped in so that we could we could help each other, and your chemistry portion does not get affected. Okay, that's why I'm here to teach you inorganic, and he will be taking care of organic and physical chemistry. Don't worry about it. Okay, so while he is busy in a lot of other places, let's complete inorganic till then. At least something will be getting completed. No, don't worry. Okay, somebody is telling me aluminium. Are you sure? Really? You really think that aluminium will be the least metallic character? Are you absolutely sure? Think again. Think again, bacha. I want you to think again. Okay, now this room is getting a little hot, so I am just going to switch this on. Yeah. Boron, somebody says aluminium, someone is still saying aluminium. Bacha, how is it going to be aluminium? You know that in a group, yes, in a group, the metallic character increases. Mostly, you start with non-metals, and then as you go down, you mostly find metals. There is non-metals, metalloids and metals, isn't it? So, boron is the non-metal. If boron is a non-metal, then obviously it will show the least metallic character. Correct? Do I make sense, everyone? Understanding, everybody? So, boron is a typical non-metal, as we can see right here. Isn't it? Aluminium is a metal, but it does show many chemical similarities to boron. However, we know that boron will be the one that will show the least metallic character. Okay? If possible, write the questions down. Yes, next question. Tell me, which one of the following has the lowest melting point? Oh, come on. This is actually a, class 8 standard question. If this comes in your NEET question or JEE question, you should be like, you should start dancing probably, like balle balle, first dance, then probably write it down. I can't believe it, Alvin, you're still telling me aluminium. Seriously, the moment you take aluminium foil on your hand, does it melt? Does it melt? No, right? What is it going to be? Of course, the correct answer is going to be option C, gallium. Yes, gallium has very low melting point. In fact, the moment you take it on your palm, it starts to melt. So it is gallium. Okay, it is gallium. Don't make silly mistakes. There is no room for silly mistakes in JEE and NEET. You have to be absolutely careful. Anyway, which of the following does not form M3 plus ion? Again, once more. Think about group 13 and 14, the first P block session that I have taken. Yes. Salar Whitey, you are right now. Yes. Dakshin, okay, very good, very good. Let's see. Balaji, very good. Some of you are actually giving me correct answer. Which of the following does not form M3 plus? Okay, now that some of you have answered already, can you tell me what is the reason why is it that boron does not form M3 plus ion? I've actually showed you the answer also. But tell me, why is it option A, and why is it that boron does not form M3 plus ion? M3 plus ion as in boron will have to get rid of some electrons, right? And boron cannot do that. Not because of inert pair effect, gaming with one. It's because of small size and high ionization energy. Yes, high ionization energy. That's why boron cannot form 3 plus ion, B3 plus ion, and you know that ionization energy also decreases as you go down the group. The sizes are bigger, so that way it will be easier for you to take away one electron, right? But for boron it is not so the case because it's a very small size, right? Moving on, next question. So this you can see, this is a previous year question. Everybody, NEET 2018 had this question. Now tell me which one of the following elements is unable to form MF6 3 minus. Once again, it's going to be a very easy question. Let me know, everybody. Tell me, where is helium, Baba? Salah, where is helium? I do not see helium anywhere. Is it gallium, aluminium, indium or boron? Tell me. Okay, I see some correct answer. I see some correct answer. What is the correct answer? Of course, boron. Once again, boron belongs to the second period. It's right on the top. Yes, and it does not even have vacant d orbital. So how is it going to form an MF6? Where will it push all the 6 electrons? Where will it push all the 6, where? Like, it does not even have space. So imagine I have a very chottu room, okay? I stay in 1 BHK, and then if 6 students tell me that, ma'am, we are coming to Bangalore, we will come and stay in your place. What will I do? I think I'll do a huge face palm and I'll sit like this, that okay, my students are coming, but I do not have place in my house to keep them. I will have to book hotel room, right? I will not be able to keep you in my house because I only have 1 chottu room. So how will I put you up there? Are you understanding? The same thing. Boron belongs to the second period, very small size. How will it be able to take in, 6 electrons? It will not be able to, right? It will not be able to. It's impossible for boron, okay? Very good. Now moving on. Next, thallium shows different oxidation states because it is a transition element because of inert pair effect, because of its amphoteric character or because of its high reactivity. Think again. Thallium shows amphoteric character? No. For amphoteric character, we know that aluminium and zinc, they are the biggest exhibitors of amphoteric character. Now you tell me. I can see some question. I can see some answers. Very good. Angaquin, Mahiz, Alvin, well done. Some of you are giving me the correct answer. The correct answer is of inert pair effect. Yes, thallium can show 2 different oxidation states, right? +1 as well as +3 because of inert pair effect. What is inert pair effect? The NS2, right? The outermost S, right? The outermost S, they say that no, we are not reacting. Why? Because the nuclear charge is enough for it to pull close. Are you understanding? For example, see, if I make it like this, if this is your nucleus, then you have electrons here, you have electrons here, you have electrons here. So only these ones will be reacting, but these ones here, they will be like, oh, actually, you know what, the nucleus is calling us, so we can't react, sorry. They will stay back. Are you understanding? That's your inert pair effect, okay? Got it? Hi Suji Venkateshan, how are you? This question came in class 11. Yes, because the boron family and the carbon family belongs to class 11, bacha. That is why, okay? You are attending here for the first time. So glad. Welcome to Vedantu Enlite and welcome to my class, okay? Moving on, everybody. Now, the stability of +1 oxidation state among aluminium, gallium, indium and thallium increase in the sequence. This you can tell me. This is again a previous year question. These type of questions like this come a lot actually. Okay, these type of questions where you have to identify the series and all of these, it does come. Plus you also have to be very careful about the sign. Okay, please be very careful about the signs, everyone. Take a look at the signs always. Sometimes what is there is sometimes instead of greater than they will put lesser than, and that way you get confused. So please be very careful. Okay, some of you are telling me option B. Some of you are telling, mostly you are telling me option B. Okay, let's see. Very good. Option B is the correct answer. Lower oxidation state becomes more stable on moving down the group. Yes, lower oxidation state become more stable on moving down the group. Got it? Yes, we know this, right? We have learnt about this also. Boron does not form Yes, Salar. Very good, very good. Do you take class regularly? Yes, Balaji. So every Monday, every Friday and every Saturday, you will be able to see me. Okay, every Monday, Friday, Saturday. So the beginning of the week and the end of the week will be with me. Will be with Nabamita Ma'am. All right. Yeah. And the rest of the week is only for your studying other subjects. Cool. Alright, moving on. Next question. Which metal is protected by a layer of its own oxide? I've taught you this also. I have taught you this. Tell me, this is very easy. See, these are the kind of questions that for which you don't even have to pick up your pen. You can just answer like tuck, 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 tuck. You can answer, okay? Alright, so tell me, everybody, which metal? Kanan, very good. Kanan, Balaji, well done. Kya baat hai? You guys are already doing great, huh? Already doing great. So you have to tell me how many seats do I save for you this time for your felicitation program? Huh? By the end of the year, how many seats do I have to save for you all for the felicitation program? Seems like a lot of you are going to crack this, isn't it? Yes? Hi Space Station, welcome, welcome. I'm good, Krishna, I'm good. Okay, aluminium, very good, yes. Now tell me, okay, this is a slightly tricky question. Look at it very well, okay. Aluminium chloride in acidified aqueous solution forms a complex A, okay, in which hybridization state of Al is B. What are A and B respectively? Salar, very good. You are telling me the right answer. So that means that we can write it as AlCl3, right? AlCl3 in acidified aqueous solution. Aqueous solution, that means H2O. In acidified, that means there are H plus ions. Yes, it gives you a complex A. Okay, it gives you a complex A. Now, what is the hybridization? The hybridization is supposed to be B. So, what is the hybridization that you get here? Yes. Very good, very good, very good, very good. Well done. Many of you are giving me the correct answer. Yes. So, the A will be the compound that they are forming is basically this, isn't it? The compound they are forming is actually no. The compound that they are forming will be this AlH2O6 3 plus. Okay, this is the compound. This is the compound. Now, if there are six, then what is it that they are forming? Yes. Chalo, let's write it down. Let's write it down properly. Okay. What is the atomic number of aluminium, everyone? The atomic number of aluminium is 13, right? 13, isn't it? Yes. Now we know that it is 3 plus. See, 3 plus. That means it will be 10. It will be 10, correct? Yes. So if I have to write it, somebody still you are telling me D. Why is it D? How is it D? Guys, Kanan, very good. Kanan, very good. Well done. Yes. It's not D, it's not A. Guys, look at it. I've already written the answer. I've already written the answer. You're still not looking at it. Suresh, very good. Yes, very good. Okay. So that means if it is 13, then how are we going to make it? We are going to write it as S. So here, right? Then there is P, 1, 2. So it will be 1. See? Right? Are you getting it? Yes? These are the 3 outermost electrons. But you know what? It also has vacant d orbitals. So 1, 2, 3, 4, 5, right? Vacant d orbitals are also there. But just now I told you that if it is 3 plus, that means it will be what? That means these electrons will be gone. These electrons will be gone, right? Yes. If these electrons are gone, that means H2O will come and bind here, 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 here and here. So 1, 2, 3, 4, 5, 6. 6 H2O. See? 6 H2O. That means sp3d2. Okay? This is the answer. Option B is the correct answer. Got it, everybody? Well done. Wow. Coordination compounds. Remember, this is slightly related to coordination compound. It is sp3d2. Okay? sp3d2. Alright? Yes. Okay. Yeah. This is the correct answer. Very good. See, we derived it already. We got our own answers, isn't it? We got our own answers, right? Very good. Everybody understood this, no? If you haven't understood, please watch coordination compound session also once and then watch the P block also. Both of them you have to watch. Both of these are very important chapters. Bacha, both of them, both coordination compound and P block does have quite a lot of weightage and you have to study it properly. Alright? Moving on. Yes, it is octahedral. Yes, it is octahedral. Alright, next question. This is from your JEE Main 2019, okay? The correct statement regarding group 13 element oxides are: boron trioxide is acidic, oxides of aluminium and gallium are amphoteric, and oxides of indium and thallium are basic. Tell me which one is the correct statement here. Okay. Which one is the correct statement? This is again very basic, very fundamental question. Very fundamental question. You can, just read it and you feel like, really, this question was asked in JEE. You feel like this, no? Don't you feel like this? Huh? Don't you feel like this? I felt like this, seriously. The moment I read this question, I felt like, really, JEE asked this question. So easy. Super easy. Glory? Glory? Okay. Alright, everybody. What do we have? B, Al, Ga, In and Tl, isn't it? Now, what do we know? This is a non-metal. This is a non-metal, right? Yes. Then we know that metallic character increases down the group, correct? All of these are metal. What do we know? Non-metallic oxides are acidic in nature. Don't we know this? We know this since class 7 or 8, my dear students. You have learnt it. I have taught recently, I have taught in class 8, metals and non-metals chapter, you have read it. Metallic oxides are acidic in nature, isn't it? And non-metallic oxides are acidic in nature, I'm so sorry. And metallic oxides are basic in nature. So non-metal, bacha, boron is a non-metal. Obviously, the oxide is going to be acidic. So option A, 1, the first statement is correct. Aluminium and gallium are amphoteric. We already know about aluminium and so does gallium. Oxides of aluminium and gallium are amphoteric. That means they act like an acid or they act like a base, right? And oxides of indium and thallium are basic. Again, from very basic class 8 concept we know metallic oxides are basic in nature. Do we not know this? Do we not know this? We don't know this, right? It's very easy. Yes, very easy. Just read the question properly. Majority of the mistakes happen just because you haven't probably read the question properly. Yeah? Anyway, do we understand this? Is this clear? Is this clear? Yes, Salar, absolutely right. Is this clear or not? Can I have some thumbs up? Should we move ahead or do you want me to take a break? Because there are some questions that we have done already. What is the exact difference between acidic and basic? Bacha, you will have to go to the lower grades now, huh? What is the difference between acidic and basic? You tell me. Basics, are you seriously asking me this? Johnny, which class do you belong to? Yeah? Which class are you in? Huh? Basics have OH minus, acids give you H3O plus, right? This is the major basic difference. Anyway, moving on. Next question. Hello Tarun, how are you? Okay. Which of the following does not react with aqueous sodium hydroxide? Tell me. Which of the following will not react with aqueous sodium hydroxide? Think. You can do this. Think. Mr. Unique Boy, this is for both NEET as well as JEE because these are 50 important questions that we are doing from P block, okay? Thank you so much, Commando Training. Thank you so much. Salar, aluminium is amphoteric, no? Yeah? Aluminium can react, don't you think? Option A, boron. Very good. Boron will not react with acid or alkali even at moderate temperature, okay? Even at moderate temperature, it is not going to react. Got it? Yes? It does not. It does not. Anyway. When Al is added to NaOH solution, what will you get? No action takes place, oxygen is evolved, water is produced or hydrogen is evolved. Come on, this is very easy. You can do this. Tell me. What will happen? Who is that? Very good. Gurrapu Parsharamulu. Sorry, I took some time to read your name, okay? When Al is added to NaOH solution, what happens? Hydrogen is evolved. Yes, hydrogen will be evolved. Correct? Yes, hydrogen will be evolved. Anyway, moving on. Chalo. Boron forms covalent compound due to. Why does boron form covalent compound? This is also very easy. I think in one go you will be able to find it out. What is the answer? Are you sure? Just option A. Aditya, very good. Very good. You guys are giving me correct answer. Well done. Yes, both A and C. Because of higher ionization energy, it's very hard to take away one electron from boron. And of course, it has very small size as well. So, it will not be able to form covalent compound. Correct? Do we understand this? We do. Now, NH3 and BF3, they form an adduct readily because they form, okay. Space station, madam, you are saying that boron is a non-metal and it's in acidic nature, but it does not react NaOH. No, it does not react with NaOH. No, but I did not say that boron. I did not say that boron is acidic in nature. I said boron oxide, right? Oxides of non-metals are acidic. There is a difference. There is a difference. I did not talk about the metal. Yes, I spoke about the I did not spoke about the element. I said that the non-metallic oxide is acidic in nature. There is a difference, okay? There is a difference. Please do listen to me carefully. Yes, Arta, I am here, so obviously I'll tell you that Vedantu is better, no? Yeah, of course I'll tell you that Vedantu is better. Anyway, moving on, everybody, come back here, come back here. No, we are not going to talk about all those things here. Please come back, everybody. NH3 and BF3, they form an adduct readily because they form what? What do they form, everyone? What will they form? Somebody is saying here A, someone is saying B, someone is saying something else. Huh? How is this going to happen? In Telugu channel, when will videos be uploaded? I don't know. The correct answer is coordinate bond, okay? Why? Do you remember? We read about NH3. We read about NH3 being a... Do you remember? We spoke about NH3 in the coordination compound also. Yes, in the coordination compound chapter. Do you remember this, everyone? Yes? Do you remember it? Or no? You are done with coordination compound. So, poof! Let the idea go away. Is that what happened? Huh? Is that what happened? Very good. Okay. Yes, Kondinya Sharma. Very good. Okay. So basically we know that NH3 can what? NH3 can definitely give some electrons, right? Whereas boron is like, I'll take some electrons. I'll take some electrons. So we know that boron, yes, reacts with Lewis bases. Which one is a Lewis base? NH3 is a Lewis base. Okay. Whereas boron trifluoride, this acts like a Lewis acid. So a Lewis base and a Lewis acid, they react together. Yes, they react together, and that's how they form a coordinate bond. Yes. Can you say next class about chemical equilibrium? Cruel Manoj Gaming, sweetheart, we are not gonna do chemical equilibrium after this. After this, we will talk about D and F block. Okay. After this, we will talk about D and F block. All right. Yes, and then maybe we will see. We also have to study chemical bonding. Chemical bonding is also very important. Yes, I am JEE student. Yes, you can see it is written Vedantu Enlite JEE and NEET. So whatever classes we take here, all of them are for JEE as well as for NEET students, right? For both, okay? Chalo, moving on. What is the formula of mineral borax? Borax I have taught you in the P block first session when I was taking you through boron family and carbon family. We spoke about borax as well. We spoke about orthoboric acid as well. So if you have seen that, if you have watched that session, then you know the answer. Yes, Glory Angel, no, wrong, bacha. Janvi, Balaji, Tej, very good. Yes, this is the correct answer. Okay, this is the correct answer. Please do remember that it is, okay, it is Natu before 07. How will you remember? Just keep saying this. Natu before 07. Okay. Natu before 07. Alright. Let's just say, like what happens? Natu in Hindi means someone who is of a shorter height. Okay. So Natu before 07. Let's just consider that 07 is tall. So Natu before 07. That's how you remember it. Okay. Just keep saying Natu before 07, Natu before 07. And then you obviously will write 10H2O. That's it. That's your mineral borax. Okay. I can't start anything, only 7 months left. How will I crack NEET? Please help me. +2 student. You have a doubt? You are a +2 student from that's class 12, right? Don't worry about it. Start right now. NEET chemistry is actually comparatively easy. It's just a little vast. You have to study everything properly. Start from right now, from today, right here, right now. You start right now, you will get there. But don't delay it more. Start right now. Start from inorganic. I'm taking care of inorganic, right? Let's finish the dry subject first. Let's complete the notes and everything. And after that, we will go to organic and physical also. That also you will absolutely kill it. Don't worry, okay? Chalo, moving on. In borax bead test, which compound is formed? Does anybody know this? Does anybody know this? Firstly, shall we understand what is this borax bead test? Should we understand what is this borax bead test? Or do you know? Do you know, everyone? Some of them are. Thank you, Fresh. Thank you so much. Tell me. What do we do in the borax bead test? Modern man, that's shooting for stars, huh? That's aiming for the stars. 10 days you'll be able to finish organic chemistry. Huh? Are you devising, or are you like, everything will be like, oh, baapare, that's a lot. I mean, being a teacher also, I don't think I'll be able to complete the whole organic chemistry in 10 days. Quite difficult. All of you are saying orthoborate. Actually, no. Elvin is the only one who has told me that it is metaborate. It is metaborate. Chalo, let's understand this. So what happens in this borax bead test? What do you understand by bead? What do we understand by bead? When I say bead, what do you understand this? What do you understand by this? Bead means, you know those beads that you put in your necklace, right? Yeah. So kind of like that structure only forms. So basically what you do is you take a platinum, spiral kind of something, right? You take a platinum, something like this. You heat it. And then you put it in the borax, right? And then you put it in the borax. Now what happens is, the first thing that will happen is, take a look at this. Do you see this 10H2O? This 10H2O? Because the platinum rod is going to be very, very, very hot, do you understand the first thing that will happen is this 10H2O, it will fly away, right? It will leave. It will be like, oh, I'm evaporating, bye. It will evaporate and it will leave. Now what happens is, this part is left. So this part, it starts to swell up, okay? It starts to swell up. And it forms what? It forms this bead kind of structure. And when this bead kind of structure is formed, there is sodium metaborate and boric anhydride, okay? Please remember it. What are the two things that I said? You get sodium metaborate, alright, sodium metaborate, and you get borax anhydride. Is that what I told you? Yes, boric anhydride. Sorry, you get boric anhydride. Alright, so that means that your correct answer is metaborate. What do you get? You get metaborate. Got it, everybody? Yes, got it, everyone? Am I making it clear? Or you are not understanding? Did you understand what is borax bead test? How do you do it? What happens in it? Everybody, can I get some thumbs up or anything? Just let me know that you are understanding or not. Come on, people. Balaji understood. Everybody else? Pinky, thank you so much. Thank you so much. Alvin also understood. Kukumalu also understood. Great. Baki ke bacche? You're not understanding. Satvik also understood. Okay, sure. Moving on then. Okay, moving on. So this is the whole reaction. Okay, this is the whole reaction. As you can see, this 10H2O, this will leave. So you have sodium metaborate. From sodium metaborate, again you will heat it. It is still getting heated. It is still getting heated up, right? Because the platinum rod was very hot. So it will form this boric anhydride and sodium metaborate. Got it? Clear. Alright, moving on. Orthoboric acid. We spoke about orthoboric acid. Tell me, orthoboric acid I have taught you in the first session of P block. If you haven't watched it, that was a recorded session, but please do watch it, okay? Please do watch it. Tell me, what orthoboric acid is? Donate proton to form H2BO3 minus, accept proton to form H4BO3 plus, donate OH minus to form H2BO2 plus, or accept OH minus to form BOH4. Tell me. Come on. Okay, I can see mixed answers, guys. Somebody is telling A, someone is telling A, D, someone is telling something else. What is the answer? The answer is D. The answer is D. Good, good. Except OH to form this. Okay, see. BOH3. Okay, that's your orthoboric acid. Plus 2 HOH, it will form this and this. Okay, got it everyone? Understood? This is the orthoboric acid. Someone is asking, no ma'am, what is the formula for this? Here, right here. Chal, moving on. H3BO3 on heating up to 373 Kelvin yields what? Boric anhydride, orthoboric acid, metaboric acid or tetraboric acid. Now think what I have taught you. Think what I have taught you. I have taught you all of these. Think, think, think. Metaboric acid. Metaboric acid, okay. H3BO3 is also orthoboric acid. So when you heat it, you get metaboric acid. Cool? Alright, you have to remember this. Bacha, do me a favor, no? Everyone, I need a promise from you, okay? Everyone, promise me that, so today is my class. After that, I'll meet you on Friday, right? So you have Tuesday, Wednesday, Thursday. Tuesday, Wednesday, Thursday. You have 3 days. In these 3 days, please go through the first P block session as well as the second P block session once, both of them, and write down. Make the notes. Please make the notes. 3 days is enough. 3 days is enough for you all to make the notes. Will you all please do it? This will help you. It will help you in solving all of these questions. Okay? Please remember the, remember the reactions. Please go through the notes once so that you can remember all of this. Okay? Chal, moving on. Boric acid is polymeric due to its acidic nature, the presence of H bonds, monobasic nature or its geometry. Polymeric, what do you understand by polymeric? That means monomer, 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 monomer. It's like a long chain. Why is it forming a long chain? Why will it form a long chain? Why? Use your common sense. Use your common sense. This is a common sense question, everybody. It's a common sense question. I'm giving you a huge hint. I'm giving you a huge hint. Tell me something. Okay. Your common sense says that because of its acidic nature. Then why are all the other acids not forming polymers? Tell me. Very good. Now you got it, Anger Queen. Yes, it is because of presence of H bonds. See how the H bonds are there? See? See? Because of this, they have a polymeric structure. Yes, they have a polymeric structure. Absolutely right. Absolutely right. Okay. Alright. Now what is BOH3? What is BOH3? Again, you know this. You know this. Is it a monobasic acid and weak Lewis acid, or is it monobasic and weak Bronsted acid, or is it monobasic and strong Lewis acid, or is it tribasic and weak Bronsted acid? Come on, yeah, you should know this. You must know this. You must know this. You must know this. Come on. You know this, everybody. The answer is monobasic. Please remember that it is monobasic. Okay, it is monobasic. Boric acid is a weak monobasic acid. When I taught you, it was clearly written. One line was written there. If you just go through the P block, the first P block session notes, you will actually see that it is written. Clearly, it's written there that boric acid is a weak monobasic acid. You will be able to see it. And it is not a protonic acid, but it acts like a Lewis acid, okay? By accepting electrons from hydroxyl ion, alright? Yes? Which chapter you take after completion of P block? I'll take DNF block, okay? I'll take DNF block, and after that we will go to S block, because S block is comparatively easy. We can do it. We are already done with this periodic properties and everything. So now all of these block chemistry will look very easy, okay? Block chemistry will look very easy. Anyway, coming back to it. Which is false in the case of boric acid, H3BO3? It acts, see, very, very close to what we just read. It acts as a tribasic acid, it has a planar structure, it acts as a monobasic acid, or it is soluble in hot water. You know it very easy, very easy. You just did it. Very good, Commando, very good. Venkateshan, very good, absolutely right. The correct answer, very good. The correct answer is this. This is incorrect because we just read, no, boric acid is a monobasic acid. So how can it be monobasic as well as tribasic? Not possible, no. Yeah. I can't go and tell around people that I have a 1 BHK but there are 3 bedrooms in it. What will be that? That'll be like me being hypocritical, paradoxical. Why am I contradicting myself? How can I go and tell people that I have actually, I stay in a 1 BHK but I have 3 bedrooms? It's like saying that. How can it be monobasic as well as tribasic, right? We just spoke that it is monobasic. So anyway, we understood that, right? Moving on. Now, in the reaction of 4BF3 plus 3LiAlH4 gives you 3LiF plus 2X. What is X? What is X? Some of them are PYQ, some of them are your practice questions, and some of them are questions that were curated by our SMEs so that you can practice. Okay? Chalo, batao. Answer, guys. Answer. 4BF3 is reacting with lithium tetrahydrido aluminate. I think. Lithium tetrahydrido aluminate. Yes. Okay. Somebody is saying A, someone is saying B, someone is saying whatever, someone is saying whatever. The correct answer is option B. Sorry. Option B is the correct answer. B2H6. Okay. Yes. This was again diborane. We have read this also. I have taught you boric acid, orthoboric acid, diborane. Diborane has that banana shape, remember? Diborane has that, remember? Those who have watched the first session, you will definitely know it. Yes. The simplest boron hydride known is diborane. It is prepared by treating boron trifluoride with this in diethyl ether. Okay. So it forms B2H6. Cool. Moving on. Inorganic benzene. Oh my god, this is so easy. Inorganic benzene is which one? Which one is inorganic benzene? Come on. And what is the other name for it? What is the other name of inorganic benzene? What is the other name of inorganic benzene and which one is it? Very good. Kukumalu, it looks like you have studied everything. Super proud of you, bachas. Super proud of you. Yes, the correct answer is borazine. It's inorganic benzene. It is B3H6N3. Okay. B3N3H6 or B3H6N3. Alright. Good. Very good. Borozone, no. Borazine. Okay. Now, the bonds present in borazine or inorganic benzene are... Can you count? Can you count and tell me what's the answer? What's the answer? Do you want to count and tell me? No. The correct answer is option B, bacha. Yes, there are 12 sigma, 3 pi. Okay? 12 sigma and 3 pi. 2, 3 and then rest you can calculate. Okay? Rest you can calculate. Alright. Okay, great. Now the structure of diborane, B2H6, diborane, that banana shape, what does it have? 4 2C2E bonds and 4 3C2E bonds. 2 2C2E bonds and 2 3C3E bonds. 2 2C2E bonds and 4 3C2E bonds, or 4 2C2E bonds and 2 3C2E bonds. Think. Again, mixed responses. Mixed emotions you are giving me. D, C, A, everything, B, everything. So obviously one of the answers will be correct. No, A or B or C or D, no. There is no clear construct. Answer is option D. Option D. Yes. 4 2C2E, that is C. This 1, 2, 3, 4. Right? And then there are 3C2E, 2 bonds. 2, 3C2E. Okay? These are the 2 3C2E bonds. Okay? It is option D. This also I have taught you. Now very related to this, another question everyone. This you can tell me. In diborane what happens? There are 4 bridged hydrogen and 2 terminal hydrogens. Seems wrong, no? 2 bridged hydrogens and 4 terminal hydrogens, or 3 bridged and 3 terminal hydrogens are present. Which one looks correct? Definitely 4 terminal hydrogens are there. We just saw 4 terminal hydrogens are there. Then obviously there are 2 bridged. See, 1H, 1H. Here, done. So boron family, I hope that it is all clear to you. If not, then please watch the previous session. Now, look at this. Which of the following compound is not matched correctly with its structure? Aluminium chloride. What is the structure? Borazine, diboron, boron trichloride. Very good. RD gaming, you have already told. Yes. See, this is not correct. This is not correct. Here there is supposed to be a Cl, isn't it? There is supposed to be a Cl. See, this is the actual structure of AlCl3, that is the dimer. Right? Okay? Moving on. Diboron upon hydrolysis. I have taught you this also, Baba. I have taught you this also. Chalo, tell me. Diboron upon hydrolysis, what does it give you? Boric anhydride, metaboric acid, orthoboric acid, or is it boron oxide? Quickly guys, we have 10 minutes. Let's quickly finish it. I'm hungry. I'm super hungry. Orthoboric acid. Yes. Diboron upon hydrolysis gives you orthoboric acid. Okay. This is also already taught. So there is nothing much that I can explain because I've already taught you this. Watch them. Watch the sessions. Reactions of diboron with ammonia gives initially what? What does it give you initially? Is it option A, option B, option C, or option D? Again, I see mixed responses. The correct answer is option D. Okay, what do you get? You get option D. This is what you get. See, this is what you get. This is what you get. Okay, reaction of ammonia with diboron will initially give you B2H6 2NH3, which is formulated as BH2NH3 2 BH4 minus. Further heating gives you borazine. So, yeah, borazine and B3N3H6 known as inorganic benzene in view of its ring structure with alternate BH and NH groups. Okay, this is also taught. Guys, how many of you have actually watched the first P block session? Honestly, tell me. How many of you have watched the first P block session? Have you all watched it or not? I recorded it on the day of Diwali just so that you don't miss out on your studies. Did you all watch it or not? Not me. Funny shots. Promise me you will go back, you will watch it and you will make your notes. Otherwise these things... right? Watch it, okay? Watch it, make your notes. Alright? Please do make your notes. Yeah? It's there. It's already there. Do watch it and make your notes. If you don't make your notes, it's going to be too late. Where will you study then? And it's always better to make your own notes. If you don't make your own notes, it just feels like, you know, you're just pouring water and water and water, but there is a hole in that whole vessel and it just keeps leaking. So make sure that you have your notes. The moment you have your own notes, you have made it on your own, so you know when to study, how to study, what to study. Everything will be very streamlined for you. Okay? Like I said, you have 3 days, everybody. Tuesday, Wednesday, Thursday. These 3 days, your assignment is to what? To make the notes of the whole P block. Okay? Anyway, moving on. The electronic configuration of 4 different elements is given below. Identify the group 14 element among this. Please tell me you can do this. This is super easy. Super easy. Notes consume a lot of time only while making it, right? But after that, when you are actually studying, that time it does not take so much time, no? Tell. You should know this. You should know this, very easy. Balaji, D? Are you serious? Group 14 elements. Group 14, bro, it has to be option C, no? What is the general electronic configuration? The general electronic configuration of group 14 is NS2, NP2. So this is it. This is it. Okay? Anyway, which of the following is the most electronegative in this group? The most electronegative in this group. Which one? Very good. It is carbon, my dear student. Carbon. Carbon is the most electronegative. The one that is on the top is usually the most electronegative, isn't it? Just like how fluorine is on the top of its family and fluorine is the most electronegative. However, fluorine is the most electronegative in the whole periodic table. But carbon in its own group is the most electronegative. Correct? Everybody? Moving on. Which of the following isotope of carbon is radioactive? You can't get it wrong here. You can't get it wrong here. Come on. What's the answer? What's the answer here? Answer is option C. 14C is radioactive. Yes, C14 is radioactive. Moving on. Which of the following halide is the most stable? Which of the following halide is the most stable? Tell me. CF4, Cl4, CBr4, CCl4. Where? CF4, bacha. Both of them are small, no? Carbon is also the head of its family. Fluorine is also head of the family. Both of them are of small size. Bond length is also going to be very small. If it is very small, obviously it will be very stable, right? It's not going to be easy to break it apart, right? You are not going to be able to easily break it apart. So obviously it is going to be CF4, right? Remember all of these common sense tips and tricks so that you can easily do it. Now, okay. Again, you have to be careful. The stability of dihalides of silicon, germanium, tin and lead increases steadily in the sequence of what? Tell me. Yes. Yes, Balaji, you are right, bacha. You are right. Come on, everybody answer. Come on. Done? Are we done? Are we done? What's the answer? The answer is, of course, this. Yes. The answer is, of course, this. Yes, the stability of lower oxidation state, that means +2 for group 14 element, it increases on going down the group. So the correct order will be silicon, then germanium, then tin, and then plumbum. Yes, and then plumbum. There is also another question that is related to this. Do you remember that the inert pair effect NS2 orbitals? Why is tin? Why does tin have 4 plus oxidation state and lead has +2 oxidation state? Yes. We will start chemical bonding after DNF block and S block. Okay. P block is over, almost over today. Then we will do DNF block, then we will do S block, and after that we will do chemical bonding. So that all of these can be connected with chemical bonding very easily. Alright, moving on. The main reason that SiCl4 is easily hydrolyzed as compared to CCl4 is that Si-Si bond is weaker. SiCl can form hydrogen bonds, or SiCl4 is covalent, or is it Si can extend its coordination number beyond 4? You tell me. You should be able to answer this. You should be able to answer this. And you missed your previous question. No problem. Just rewind it a little bit and you can do it, okay? Some of you are saying C, some of you are saying D. The correct answer is D. Correct answer is D. Remember, carbon cannot extend its coordination number beyond 4, but silicon can. Yes, silicon can. Absolutely. Why? Why silicon can? That's because it has vacant orbitals, vacant d orbitals, isn't it? But carbon has absence of d orbitals. It just cannot. It just cannot. Okay. All right. Moving on. Catenation, that is linking of similar atoms, depends on size and electronic configuration of atoms. The tendency of catenation in group 14 elements, what does it follow? Which order does it follow? Come on, you know the answer. It's very easy. Is it option A? Is it option B? Is it option C? Or is it option D? Come on, everybody. Yes. Yes, Azan. I teach 8th, I teach 10th, I teach 9th, I teach 11th, I teach 12 also. Okay. I teach from class 6 to class 12. Everything, bacha. I teach all of it. Okay. Some of you are telling me B. Some of you are telling me very good. I'm so proud of you. Those of you who got it that it is option B. Well done. Well done. We know about catenation, isn't it? We know that carbon has this tendency to link with one another, isn't it? Yes, catenation is the highest in carbon. We have read about this already. But germanium and tin, they don't have so much of this power. They don't have this power so much, right? And lacto does not show only. Lacto does not show only, right? Yes. Okay. Moving on. The element that does not show catenation among following P block is, you tell me. We just read about this. Is it carbon, silicon, germanium or lead? Which one is it? Yes, yes, Balaji. Carbon is the king of catenation. Yes. Very good. It has to be lead. We just read it, no? That lead does not show catenation at all. Very good. Which of the following is incorrect statement? Okay, tell me. This has also come in the NEET 2019. This is also previous year question, as you can see. Tell me. Is it PbF4 is covalent in nature? SiCl4 is easily hydrolyzed. We know about this already. We have read this some time back. So option B cannot be incorrect. GeX4. X can be fluorine, chlorine, bromine, iodine is more stable than GeX2. You tell me. SNF4 is ionic in nature. What is the correct answer? The correct answer is option A. PbF4 is ionic in nature because of its high electronegativity difference. You see, Pb is almost at the end, F is right at the top. There is a huge electronegativity difference, isn't it? And that's why it is ionic in nature. Option A. Option A is the incorrect statement. Okay? Alright, option A is the incorrect statement. Moving on. Which of the following species is not stable? It is not stable. Batao. Let's see. SiF6 minus, GeCl6 minus, SnOH6. Okay, these two possibly can. Right? SiF6, SiCl6. What are your thoughts about these two? Germanium will have vacant d orbitals. So will Sn. Sn will also have its vacant d orbital. But what about SiF6 and SiCl6? What are your ideas about this? The correct answer is option D. Okay, option D is not possible because 6 large chloride ions cannot be accommodated around Si4+. Silicon also is almost on the top of its family, isn't it? It's not at the bottom, it's almost at the top. So that means that the size is not that huge like germanium and tin has. Germanium and tin will have rather bigger size than silicon, isn't it? Now why is F6 possible? Why is this possible? That's because we all know that fluorine has a very chotu size, right? Fluorine is the dawn. We all know that fluorine has chotu size and we all know that fluorine is the most electronegative. So this is possible. But this chlorine is slightly bigger than fluorine. So that way it becomes a little problematic, okay? That way it becomes a little problematic. Understood everybody? Got it? Moving on. It is because, this is the question that I was telling you. This is exactly the question that I was telling you. Sometime back I was talking to you, know, about tin and lead. Yeah. It is because of inability of Ns2 electrons of the valence shell to participate in bonding that Sn2 plus is oxidizing while Pb4 plus is reducing. Sn2 plus and Pb2 plus are both oxidizing and reducing, or is it Sn4 plus is reducing while Pb4 plus is oxidizing, or is it Sn2 plus is reducing while Pb4 plus is oxidizing? Let me know, let me know. Thank you so much, Venkatesan. Thank you so much. Tell me what's the answer. Salar, it feels like you're a little late. Which question are you answering? You're telling me B. B is wrong. Both of them cannot be oxidizing and reducing. Tell me. The answer is D. The answer is D. Okay. Sn2 plus is reducing. Alright. Okay. Sn2 plus is reducing. Whereas Pb4 plus is oxidizing. Why? Due to inert pair effect. Okay, due to inert pair effect, the Ns2 electrons, they say that, hey, you know what, the nucleus is pulling us quite enough, so we are not going to bond. Okay, we are not going to go for anything. We are not just going, we are going to stay here only. Yes, C and D options are not same. Balaji, take a look at this. Here it is written Sn4 plus, but here it is tin 2 plus. This is tin 4 oxidation state and this is tin 2 oxidation state. There is a slight difference, okay? Yeah, so due to inert pair effect, we see that the lead 2 plus is more stable, okay? So lead will only give away the P electrons, okay? The lead will say that, okay, you take away my P electrons, but I am going to keep my Ns2 electrons, okay? Whereas that's not the same thing with tin. Alright, got it? Now SN4 is more stable than SN2. SN is like, you know what, take all of them. Take all the 4. I'm fine with it. I'm fine without it. So it will give away all the 4, but lead will not give away all the 4. Lead will say that, you know what, just take the P, don't take my NS2 electrons. Got it? Understood, everybody? Yes, so this is what happens. Now, in graphite, electrons are, oh come on. Whew, super easy. Super easy. Acha Harini, no problem. Next time I'll ask my SME to make it slightly bigger for you. But I feel like you can easily see it. Are you watching it on your phone? Maybe that's why you're finding it even more small, no? Localized on every third car. Nah, you know this. Localized on each. Ayya. Boys and girls, you have read about graphite from a very young age. Don't make a mistake here. The answer is option D, no baba. It is spread out between the whole structure. Yeah, it is spread out between the whole structure. Chal, moving on. Which of the following is not correct about carbon monoxide? Okay. You know about this. See, you know why I keep telling you class 8 and class 9 and class 10? Because I teach it every day, right? Even today I had one class 8 session, I had one class 10 session, and I have one class 12 session. So, you see, like everything is stored in my head. That's how it feels like. I feel like, oh no, 7th is connected to 8th and 8th is connected to 10th and 10th is connected to 12th. So, like, you know, it's like, it just pops in my head that, hey, this you studied there, this you studied there. So, that's why I keep talking about the lower grades. Please don't mind me. Anyway, yes. What are you saying? The carboxy hemoglobin bound to carbon monoxide is less stable? No, this is the one that is wrong. This is the incorrect one. This is the incorrect one because we all know that the carboxy hemoglobin is actually more stable, which is why carbon monoxide poisoning does happen. Option B is the correct answer, Ramu. Option B. Anyway, the basic structural unit of silicates is, I've taught you this also. Tell me. Is it option A, option B, option C or option D? I've taught you this. Tell me. Hi ma'am, do you remember me? Optimal learning with VR. Yes. How are you? Good to see you. Come on guys. Answer is option A. Oi. SiO4, 4 minus. Yes. SiO4, 4 minus. This is the basic structural unit. Good. Those students who are saying A, very good. Moving on. Which of the following compounds is used in cosmetic surgery? Ayah. Super easy. Can you imagine? I think you all will be able to clear NEET very easily. So easy it is. What is the answer? The answer is D, silicones. Silicones are used in cosmetic surgeries, isn't it? Yes. Silicones are biocompatible and that's why they are used in surgical as well as cosmetic plants. Moving on. In Haber's process for the manufacture of NH3, I have taught you Haber's process just yesterday. Tell me, what do you need? What do you need as a catalyst? Do you use nickel? Do you use iron? Do you use molybdenum or no catalyst is necessary? Tell me. Yeah, optimal learning with VR. I am teaching you for test. Why don't you take my test only? You take my test. Huh? Yeah. This is my NEET entrance test. No? How do I remember my students? I have to tell you. Really? What do you think I am, Einstein? I'll remember the subject also. I will remember all my students, point to the dot and where and how, you know, what all things I have done or what all things I have, whatever. I mean, what are you talking about? I seriously can't answer all of that, bacha. I remember you, I've told you, but now you are like, how do you remember me? Come on. Very good, Harini and Sanju, well done. That means you have studied, you have attended my yesterday's session. Yes, the correct answer is iron is used, okay? Iron is used as a catalyst here. Cool? Moving on. Which of the following statement regarding allotropic forms of phosphorus is incorrect? Read it. We have spoken about this yesterday. White phosphorus, red phosphorus and black phosphorus. Tell me. Till then, I'm going to drink some water, huh? I will drink some water. Chalo. Huh? Are you sure? No, the correct answer is Kaundinya Sharma. Very good. Option B is the correct answer. Red phosphorus on heating catches fire and give dense red fumes of P4O10. No. It has to be white phosphorus, isn't it? Yes. White phosphorus. This is incorrect. White phosphorus on heating will catch fire because that's highly reactive, isn't it? That's highly reactive. Got it? Yeah, absolutely. Well done. It is the white phosphorus that will readily catch fire on heating. Correct? Anyway. Basicity of orthophosphoric acid. Let me see how many of you have done that. I told you, in one sheet of paper, write all the oxo acids of phosphorus and all of it. Let's see. Orthophosphoric acid. Who has done it? Who has done it? Yes, the answer is 3. The answer is 3. Very good. You don't know the subject. What is your qualification? Yeah, now I remember. Now I remember. I know I had seen you in this channel. This was the question that you had asked me, on my very first day. This was the question you asked me, Already copied and pasted. Very good. Yes, the basicity is 3. Okay, orthophosphoric acid is, yes, basicity is 3. Very good. Well done. Moving on. I think we are done, right? We are done. Oh yeah, we are done and it's already 9:41. Yay, I can go home and eat my dinner and sleep. Okay. I did not even realize that I've taken so much time. It's more than 1 hour and it just went on and went on. Thank you so much, for making my classes so interesting. I did not get bored at all. I rather had so much fun while taking class. And I was thinking, why do I have a class late at night? I did not want to take it. But yeah, it was fun. So anyway, if you want to follow me on Instagram and if you want to stay in touch with me and get to know me, what do I do, what do I not do. Sometimes I will also post questions. Sometimes I also tell you about when my classes are happening and when my classes are not happening. So do follow me if you want to, if you are there, but you don't have to waste time and everything. Okay. So yeah, Nabamita_Nobita, that's my Instagram account, and thank you so much. Acha, by the way, I also wanted to teach you one last thing, everyone. Yesterday I was teaching you about, if you remember, 1 second. Let's take this. Yesterday I was teaching you about you want to talk to me? Yeah, I'm here for 2 more minutes. 2 more minutes I'm here. I was teaching you about group 18 elements, yes, group 18 P block, and Glory and Harini and all of you had asked me that, ma'am, why is it that the noble gases are forming compounds? Why are they forming, right? Obviously, we all know that noble gases, that means they are inert gases, right? They are not supposed to react, but why? Let me tell you. So today I have a little bit of time. I'm just going to quickly explain in 5 minutes and then I'll let you all go, okay? Acha. So the noble gases, you all know that it is what? Helium. What do you have? Arey, yahan chalega nahi. I'll take this only, okay? I'll take this. What do you have? You have helium. Tell me all this thing. Everybody, tell me the name of the noble gases. Tell me the name of the noble gases, everyone. Next class is on Friday, sweetheart. Next class is on Friday, okay? Yes, what do you have? You have helium, you have neon, you have krypton, you have xenon, and you have radon, isn't it? You have radon. 1, 2, 3, 4, 5. 5 only I have written. Which one did I make? Argon. There is argon as well here. Correct? So there are 6, right? Helium, neon, argon, krypton, xenon, radon. Now, okay. We understand that this one forms duplet. Yes, this one satisfied the duplet rule. Satisfied the duplet rule, but rest all of them they satisfy the octet rule. Correct? Now we all know that the head of the family is very tough to poke, or it's very tough to take anything away or give anything to them, right? The head of the family is a very strong character. Same here. Helium already follows and satisfied the duplet rule. So helium has no electron affinity. It does not want to give any electron either, right? The same thing with neon and argon and krypton and xenon and radon. Now radon is radioactive, so let's forget about that. But tell me something, when you are coming down the group, don't you think that it is easier to take the electrons? Ionization enthalpy decreases down the group. Am I right, everyone? Am I right? Ionization enthalpy, it decreases down the group. So that means that it will be easier for us to take away 1 or 2 electrons from xenon. Yes? Not like super easy. I mean, not like any other, elements or any other groups, but still, you still can try maybe, right? You can at least try to take some electrons from xenon, which you cannot do anywhere else, right, everybody? Yes, and that is why Glory, Anger, Harini, everybody else. Now tell me, do you understand that yesterday when I was teaching you that xenon forms compounds? This is what it is. This is why. See, because ionization enthalpy decreases, you can take away electrons from this. And you know what? It was found that xenon and oxygen almost, it's equal. It's equal, right? Yes, it's equal. For formation of compounds, the amount of energy you have to give here and the amount of energy that you have to give here, yes, it is almost similar. That's what was found. Now, will you all go back to the previous session and watch what I have taught you yesterday? Yes, comparable electronegativity. Yes, comparable electronegativity. But how, ma'am? Anger queen as in? How, for what? Why are you teaching sincerely? Oi, that's my job. If I don't do my job sincerely, who else will? Huh? Who else will? And if I do not teach you sincerely, will you even respect me enough? Will you even respect me enough? You won't, right? Yes, Anger queen. How, ma'am? Do you understand or you still have a confusion? You just asked me how. That's why I'm asking. Please tell me so that I can leave and eat my food. Yes, I think I can leave in another 5 minutes, right? In another 5 minutes I can leave, yeah. So everybody is just mistaken. Okay, so I think we are done, everybody, right? We are done here, alright? Okay, so that was all for today. Thank you so much for beautiful class. Love the class. I hope that you all did too. Don't forget to like, share and subscribe with your friends, yes, everywhere if you like the class. And with this note, tara bye-bye, eat well and good night to you all too and sweet dreams, and don't forget to do the assignment, okay? Lots of love and see ya, bye-bye.